This video is a book review, and here is the book. It's called Monosodium Glutamate Effect on Plasma Cortisol. And this is actually a big deal. It's because there's something very interesting here. I'm going to go through a little bit of the review of what's cortisol, but the gist of it is MSG. It's really not MSG, it's the glutamates, the money. The glutamate is doing something to cortisol that's very interesting and has a lot of clinical significance. So just a little bit of a quick background, because not everybody's familiar with cortisol. Cortisol is a corticosteroid hormone. All the green arrows pointing up are what it does, that it increases. And then the red arrows pointing down, those are the things that it decreases. Okay, so cortisol will increase blood glucose, because basically what's the purpose of cortisol? When you're stressed out, being stressed out is being chased by a tiger in the dark. Okay, so you have to mobilize all your energy as fast as possible so you'll have enough energy to climb a tree and somehow survive with the tiger chasing after you. So your blood glucose goes way up. Well, that increases your risk of diabetes, causes insulin resistance. Your blood lipids go way up, mobilizing all this energy into your blood. That increases your risk as well of diabetes, for example, of atherosclerosis. It makes you more hyper alert and awake. That can cause insomnia. It also retains sodium, because the sodium helps maintain your blood volume from an osmotic basis. So it's a mineralocorticoid as well, meaning that it expands your blood volume and it causes hypertension. So a lot of times in the modern world, we're not just stressed out for 30 minutes in a physical episode. We're stressed out day after day, hour after hour. And so this makes us fat, hypertensive, and diabetic. So you don't want chronic persistent elevation of cortisol. Okay. It also causes the release of increased glutamate in the hippocampus, which increases intracellular cytoplasm calcium. That's a real important point. That's absolutely key. You have to know that cortisol will increase glutamate activity, the excitatory neurotransmitter. 90% of neurotransmitters in the brain and the cerebral cortex are glutamate, and they're excitatory. They increase cytoplasm calcium. Super important to understand that. Then here's all the things it decreases. It decreases bone formation, so chronic stress is associated with more osteoporosis. It decreases serotonin. It predisposes to anxiety like PTSD, post-traumatic stress disorder, MDD. It also increases the risk of major depressive disorder, MDD. Suppresses the immune system, because you don't need an immune system when you're running from a tiger. You just want to survive the next 30 minutes, so you don't want to waste resources on that. But when you're chronically stressed out with elevated cortisol, then suppressing your immune system makes you more vulnerable to infections, makes you more vulnerable to cancer, because you can't remove the cancer cells as well. Your immune system's what does that. It decreases your sensitivity to pain. Everybody knows what it's like to get injured in the middle of a sporting event. You don't feel the pain that much, but then afterwards you do. Decreases blood flow to the gut, and that can contribute to causing leaky gut. It also contributes potentially with time to causing leaky blood-brain barrier, which can have a negative effect on cognitive function. It'll decrease blood flow to some extent to the frontal lobes of the brain, the thoughtful, delayed gratification part of the brain. And it'll keep you working in a limbic part of the brain, the middle part of the brain, the mammal brain, so to speak, which is impulsive, but it's more fast. Okay, decreases libido. You'll be a little less strong. Well, you're strong for the 30 minutes of stress. You're strong for the 30 minutes of running from the tiger from the dark. But if you're chronically stressed day after day, then you're weaker. You're going to lose some muscle mass from mobilizing all your amino acids into the blood. Okay, and where does this MSG MfG come from? MFG is manufactured free glutamate. This is monosodium glutamate. This is the idea of the bliss point. They try to get just the right amount of MSG, of salt, the sodium, of high fructose corn syrup, a sweetener, of fat, or frying it, mouth texture, to make the person just become addicted to it based on the research of the food companies. Here's MSG, and MFG is kind of replacing MSG to some extent. So you take a protein that's got a lot of glutamates in it intrinsically, like gluten itself is named after glutamate. 25% of its residues, that's an incredibly high amount, are glutamates. Casein's real high too, 1 out of every 5. Okay, soy's pretty high too, close to 1 out of every 5, and then whey is up there as well. And you just chop it up into its individual constituent amino acids. And now you've freed up all these glutamates. Because they're freed up, they're called manufactured free. What this means is when they hit your mouth and your gut, they're immediately going to activate the umami receptors, the glutamate receptors, and they can cause an intense effect. Plus, they can overwhelm the ability of the gut to sequester them. And that means they can dramatically raise your blood levels, which is not good. So here's what the cover of the book looks like, just like you saw in the picture here. And I thought it was an interesting book. So first of all, it was based on a study where this researcher, and she's kind of a young researcher. I know she's got a master's degree, or she had a bachelor's degree. I don't even know if she has a master's or a PhD, but it's still good, you know. And you know it's something special about a research paper when they make it into a book, okay? The book, she dedicated the book to the Almighty Allah. Now, some people might say, oh, that's inappropriate. Why is she dictating a book to her religion, to her God, whatever? And I'll tell you something, I think it's a good thing. You say, oh, how can I say that? That's unprofessional. No, I'll tell you why. I read research studies all the time. And I would say the majority of them, the researchers are lying, okay? They're BSing and playing games. So the fact that she's dedicating the research study to her God seems to me like she's going to be less likely to lie. Can I guarantee that? No, of course not. But that gives me a little bit more confident. I'd much rather see somebody dedicating a research study to their God than to some corporation, okay? Because that's what it usually is, dedicated to the corporation who pays the money, and the study's a bogus waste of my time. Okay, so anyways, she injected MSG into rabbits, and their cortisol level in their plasma went up. And there's numerous studies. She cited about 15 different studies where other people have done some variation on this, either injecting glutamate or NMDA agonists, things that stimulate the NMDA receptor, the one that increases calcium inside the neuron. And, you know, they all got the same thing. So that's pretty convincing. And this is highly relevant because you see how we're going in a full circle here, in a cycle, in a vicious cycle, really. Cortisol increases glutamate, and glutamate increases cortisol. You see how that can create a vicious cycle of a, you know, self-feedback, positive feedback loop worsening process. Most cortisol in the blood is in the serum bound to plasma proteins like corticosteroid binding globulin or to albumin. Only the free cortisol is active. And when you have psychological stress, that will downregulate the CBG binding protein, which makes more cortisol free. For example, cortisol in the blood, I put the page numbers on here if anybody ever wants to read it and stuff. You could say it's a little bit expensive in the sense, but I got it because it's difficult to learn all this stuff. And she did a good job of summarizing all these other research studies on MSG and cortisol. It's hard to find good research on this because industry funds lots of studies to sit there and tell you how wonderful MSG is. And like I said too, MFG is kind of replacing MSG to some significant extent. Okay, let's see. Cortisol, you know, mobilizes increased free fatty acids, triglycerides, insulin, amino acids, all in the blood. You know, causing insulin resistance, increasing your risk of diabetes. It also catabolizes, means breaks stuff down, freeing up amino acids to use for gluconeogenesis potentially. Chronic excessive cortisol can cause cell death in hippocampal neurons in rats. It can cause depression and lead to dementia. Yeah, it's excitotoxicity, overstimulation of neurons, and if they can't meet their blood supply and energy demands, those neurons could die by apoptosis. Cortisol suppresses immune function. We talked about that. Normally, cortisol peaks in the morning and helps get your blood glucose up in the morning after you break fast. You haven't eaten in a while, and that energizes you to go out and look for food. Whereas I like in the morning to study. It's when your brain is smartest. When does an animal need to be smart? When he's hungry. Okay, an animal doesn't need to be smart after big dinner. It's a good time to go to sleep. But in the morning when he's hungry, you better be smart so he'll be able to intelligently go find food. Another thing is the love hormone, oxytocin, you know, feeling comfortable and safe and loving. Okay, it will decrease cortisol. Okay, that's interesting. Glutamate will decrease oxytocin, and that can have an effect on, you know, your attitude, your relationship. And this is also, I think, why people who eat a lot of processed food, they have a tendency to be more impulsive, more anxious, because they got this cortisol glutamate thing going on and they're suppressing their oxytocin. Does that make sense? Also, cortisol is in like a seesaw with both oxytocin, and it also has a seesaw with melatonin, the sleep hormone. When the glutamate is freed up, like I showed in the manufactured free glutamate, it can enter the blood much faster and overwhelm the ability of the gut lining cells to sequester it, so you can get the blood levels up higher. When you get the blood levels up higher, you'll increase the amount that's getting into the brain. Glutamate normally can only cross the blood-brain barrier by active transport, but there's areas of the brain that don't have a blood-brain barrier, like the CVOs. Those are circumventricular organs, and that includes the hypothalamus. That's a big deal. Again, I got the page numbers on here if you want to read the book yourself. Glutamate can destroy circumventricular neurons by excitotoxicity. Glutamate's always an excitatory neurotransmitter, and again, it's like 90% of the neurotransmitters in the brain and the cerebral cortex are glutamate. When you increase glutamate in the locus ceruleus, you'll get increased release of norepinephrine, of course, but that will also cause increased plasma cortisol. And it makes me wonder, I have not confirmed this, but it makes me wonder, are the SSNRIs going to do this? It should be SNRIs. Those are the serotonin norepinephrine reuptake inhibitors, which are sometimes used to treat depression. Are they going to cause this effect? That's kind of funny if you understand it. Okay, so here now you can see, like, what does a neuron do? A typical neuron, it receives signals from its dendrites. The information comes in. It then, if it fires an axon potential, it begins at the axon hillock right here at the sodium channels, letting sodium come in. Sodium comes in, depolarizes the cell. The depolarization activates the voltage-gated calcium channels. Calcium comes into the cytoplasm at the axon terminal, and that causes the neurotransmitter vesicles to go and merge with the plasma membrane of the synaptic cleft. The neurotransmitters are then released across the synaptic cleft. They bind and exert an effect on the postsynaptic neuron. Okay, so now here's what I thought was like a really cool diagram. Here's I'm summarizing everything. So here's your MSG or MfG, and they're going to have this effect to increase cortisol. Then the cortisol has a lot of effects. Like I said, it causes insomnia. You can't sleep. It can make you anxious like you would be in the middle of a stressful physical event. It predisposes to obesity. It increases blood glucose, blood triglycerides, blood-free fatty acids. Has a mineralocorticoid effect, increasing reabsorption of sodium in the kidneys to increase blood volume. So you're going to have more hypertension. Because it's causing insulin resistance, you're going to have more diabetes. It's catabolic. You're going to have breakdown of the muscle protein, for example, when it's chronic, to free up amino acids that can be used in the liver for gluconeogenesis. Okay, so that's all pretty basic. We just talked about it, but here's where it gets interesting. Cortisol, when it's elevated, it increases brain glutamate. We just talked about the MFGs feeding into the cycle, and that's going to increase glutamate. Well, that's going to increase cortisol. So you see how you got a little bit of a vicious cycle loop going here? And a lot of people, they pile it on by their own behavior. They're stressed out, which increases cortisol, and that increases glutamate. They drink coffee or caffeine, some caffeinated beverage, for example, or take a caffeine pill. That increases cortisol, increases glutamate. They're sleep deprived quite often because they're stressed out or whatever the reason. But you can see how this kind of gets going. And basically, when you have caffeine or MSG, you're feeding the loop of stress. And because you can see how this is all pushing towards excitotoxicity, increasing brain glutamate, okay? And I actually could have put something on here for excitotoxicity. You also see how this could affect a person's mood and their personality. Because when you elevate this MSG stuff and you elevate brain glutamate, you're suppressing oxytocin, sort of the love, bonding, trust hormone. Get it? So this is bad. You're sort of pushing into a sympathetic autonomic loop. SANS and PANS are the other seesaw. And you want to spend more time in PANS, less in SANS. SANS is sympathetic autonomic nervous system, fight or flight. That's the stress response. PANS is parasympathetic autonomic nervous system. That's the relaxation phase. So SANS is like the accelerator. PANS is like the brake. And, PANS is also called feed and breed, rest and digest. So you can see this idea of a vicious cycle where not only does increased cortisol increase brain glutamate, but dietary glutamate increases cortisol and its effect on the brain. So I thought that was pretty interesting. That's actually that's an AO, academic orgasm, okay? That's really interesting. All right, and here's just showing cortisol will also bind to the axon terminal and stimulate the release of glutamate. And here was the voltage-gated channel, which we talked about, that being activated by the sodium channels. The glutamate travels across the synaptic cleft, binds the AMPA receptor, and that lets sodium come in, depolarizes the cell. Then that causes the magnesium to pop out of the center of the NMDA channel. And then it opens up and lets calcium come in. Okay, this is just showing a little more information. The glutamate's then removed from the synapse through these excitatory amino acid receptors. It then gets converted by the astrocytes, supporting cells of the brain, into glutamine, and that's safe to then send out into the extracellular space, and it goes back to the neuron to repeat the whole thing. If you want to turn down a neuron, you can use GABA. GABA is about 5% of brain neurotransmitters. It's the key thing about it, it's inhibitory. It allows chloride to come in, which further polarizes the cell, makes its charge more negative, and that can shut down the effect of the voltage-gated calcium channels, and that can also shut down the effect of the corticosteroid effect. So GABA inhibits the neurons. All right. So anyways, Oh, what is excitotoxicity? Just in case you haven't seen it before, here's my excitotoxicity slide. So excitotoxicity means too much glutamate is being released across the synapse, and it's overactivating the postsynaptic neuron. And when it overactivates the postsynaptic neuron, too much calcium gets into the postsynaptic cell, and it can activate harmful pathways that lead to cell death. In a sense, you can think of it like I talked about my supply and demand concept. If the metabolic rate gets too high relative to the glucose oxygen delivery and the ATP production capacity, the cell will just die and go into apoptosis. Okay, so anyways, I hope that was interesting and useful to you, and trust me, if you're interested in brain physiology, just general physiology, the idea of potentially having a vicious cycle where cortisol is increasing glutamate and glutamate's increasing cortisol, that's kind of scary. And you're feeding extra glutamate. You're throwing gas on the fire, basically, by ingesting this MSG MfG stuff. So processed food is really bad in a bunch of ways. This is just showing how it feeds the fire of excitotoxicity and brain damage.